This is Craig Farnham from Osaka Metropolitan University. This is a test English lecture on energy savings and policy for the Department of Human Life and Ecology. So let's start. To evaluate policy to save energy, we need to know some of the basics. So first, we'll talk about the amount of energy and what units we use. And then we'll talk about types of energy, and then the cost of energy. Then some talk about energy efficiency, and a little bit of economics and psychology and policy. Maybe not today, but in other lessons as well. So first, the units of energy. So to talk about the amount of energy we are going to save, we need to know what units we're using. Energy is often written in units of joules and calories. So joules have many definitions, but a mechanical energy definition. So a mechanical definition is a joule is the energy you need to move a 100-gram object 1 meter with 1 Newton of force. So it's kind of like moving a small apple 1 meter up or down. Heat energy definition of energy is 1 calorie, and that's the heat required to heat 1 gram of water by 1 degree C. So 1,000 calories, or 1 kilocalorie, which we know from food, is the heat required to heat 1 liter of water by 1 degree C. Joule is named after the famous scientist who discovered the relationship between mechanical work and heat, James Joule. And 1 calorie is the same as 4.18 joules about. But when we're talking about energy use in daily life, in buildings or electrical power plants, we often use watts. So what's a watt? A watt is a unit of power. So that is using or creating energy continuously over time. 1 watt is a joule per second. Every second using 1 joule. Now, for example, a big microwave oven at your home maybe uses 1,000 watts it's running. And this is named after James Watt, who invented the steam engine. And then we had trains and the Industrial Revolution. Now, 1 watt is fairly small, so we often use kilowatts and megawatts. A typical flashlight maybe uses 1 watt, or a smartphone on the low side, maybe 0.3 watts. Fluorescent light, maybe in this classroom, 1 tube uses about 30 watts. Computers use somewhere between 50 or 100 or 300 watts. An air conditioner for 1 small room maybe uses about 500 watts. A large microwave oven maybe uses 1,000 watts, or we say 1 kilowatt. The average home in Japan on average uses about 2,000 to about 3,000, 3,500 watts during the day usually, or 2 kilowatts to 3.5 kilowatts. Nuclear power plant maybe makes, you see those zeros there, how many zeros? 1, 2, 3, 4, 6, 1 billion watts. That's big. So we might say instead 1,000 megawatts or 1 gigawatt. But let's go back to normal watts. Now, electricity cost and consumption and generation data often use the units called kilowatt hours. So what's a kilowatt hour? Well, let's say there's this room with a lot of lights and it's using about 1,000 watts to keep these lights on, or 1 kilowatt. So if you use this room for 1 hour with these lights for 1 hour, it's 1 kilowatt for 1 hour, and that is a kilowatt hour of energy. So One of the goals of this class is to talk about saving energy. So a simple energy saving idea is when you're not using a room, turn off the lights. That's common sense, right? So if this is a 1000 watt lighting setup or 1 kilowatt, and you take a 1 hour break, you turn off the lights for 1 hour, you save 1 kilowatt hour. And saving energy often results in saving money too. So for us in Osaka, the cost of electricity from Dept Kansai Energy, it depends on the contract, but it's usually somewhere in the 20 to 30 yen range. For now, let's just use an average and say each kilowatt hour is 25 yen, or 25 yen per kilowatt hour. So if we go back to that example of light in a big bright room using 1 kilowatt for 1 hour, 1 kilowatt hour, the cost is about 25 yen. So let's say you forget to turn off the lights over a weekend from Friday night until the next Monday morning. That's about 60 hours, so 60 kilowatt hours, and that's a loss of 1,500 yen for this room. If you forget to do that every week, then in 1 year, that total loss becomes 78,000 yen. So it adds up. So when you're not using a room, turning off the lights saves money and electricity. Now, there are many types of energy. We were just talking about electric energy, but we also have heat energy. That's easy to understand. Mechanical energy is making things move, like motors and washing machines. Chemical energy, for example, gas, gasoline, a stove, or a rechargeable battery, or just a regular battery, uses chemical energy. Light energy is what we get from our light bulbs or the sun, etc. There are many types of energy. So usually when we use energy, we convert one type of energy into another type. Especially in our homes, we use a lot of electric energy. Now, for example, we use electric energy to make light energy with a light bulb. But when we convert energy to another type, some energy is always wasted. Usually it's by becoming heat. So when you use electricity to make light with a light bulb, the light bulb also becomes hot. And that's heat energy, and that's wasted. When we use electric energy to recharge a battery, you're changing electric energy to chemical energy. And you maybe notice that when you're recharging your phone or charging a battery, it becomes a little bit warm. So that's heat energy again, and that's wasted. The waste is not always heat energy. It can be vibration or a little bit of sound or movement, etc. But mostly it's heat energy. Oops, there's the animation. Waste heat. Okay. So let's look at an example of energy waste. We're talking about lights. So let's look at an old style light bulb called an incandescent bulb. So a 100 watt light bulb uses 100 watts of electricity and actually makes only about 2 watts of visible light energy. You can see the rest is waste heat energy, 98 watts. And this is part of the conservation of energy concept, or the first law of thermodynamics. So energy cannot be created or destroyed. It can only be converted from one type to another, or more simply, the total energy in to some device equals the total energy out, or stored, or wasted. Now here we put in 100 watts, and we get out 2 watts of light and 98 watts wasted for heat. So when we talk about devices or equipment, we talk about energy efficiency, and this shows how much energy is wasted. High efficiency is good. And the definition, well, maybe you can guess. We used 100 watts of electricity, but we only got 2 watts of light. So 2 out of 100, or 2 divided by 100, is 2%. It's 2% efficient, which is very inefficient. So the simple definition of energy efficiency also depends on the purpose. So let's look at an example of charging a smartphone while you are using it. And let's say from the electric outlet, we're getting 1, 2, 3, 4 units of electricity. And while you're using it, for the light for the screen and electric energy for the chips, you're using 1 unit of energy out. And the battery is charging. Let's say 2 units of energy are charging the battery. And it becomes a little bit warm, so maybe 1 unit of energy becomes heat. So the consumed energy is 1, 2, 3, 4. The used energy is 1. The stored energy is 2. And the waste heat energy is 1. 1, 2, 3, 4. 1, 2, 3, 4 is balanced, and that's conservation of energy. A definition of efficiency is how much useful energy versus how much consumed energy, or how much used energy versus useful energy. So if we use this graphic of 4 in, 1 used, 2 stored, 1 wasted, the efficiency is, the consumed energy is 4. The useful energy is the 2 stored in the battery and the 1 used to make the screen and the chips go. Not the heat. That's not useful. So we have 1, 2, 3, 4, 1, 2, and 3. So the efficiency is 3 over 4, or 3 divided by 4, 75% for this case. The energy efficiency is never more than 100%. If it was over 100%, that would be free energy. Like making free energy forever, which sounds too good to be true, and it's impossible. Energy efficiency is never perfectly 100% either. There's always some waste. If efficiency is over 100%, then it is likely a mistake or a lie. Maybe somebody selling something. So be careful. Now, if we use a device for a different purpose, its efficiency can be different. So before we just talked about the light bulb. To make light, it's very inefficient. 100 watts becomes 2 watts of light. The rest becomes heat. So a light bulb as a light source, its efficiency is 2%. But if you want to use it as a heater, if you want the heat, the purpose is to get heat. You get 98 watts of heat for 100 watts of electricity. So it's 98% efficient. And actually, many places, research labs, experiments, even children's toys use old style light bulbs as heaters. They're cheap, they're pretty safe, they work, they're dependable for a while. So even now, some people use them for heat. But let's go to energy saving idea number 2. These old style incandescent light bulbs are very inefficient. So if we change from low efficiency light bulbs to high efficiency light bulbs like the LED light bulbs, that will reduce our running cost. So for example, this incandescent light bulb uses 60 watts, and this type 60, so the same amount of light, 800 lumens, uses only 7 watts. So you can see almost 1/10 this. So let's imagine 1 month of use, using the light bulb for 8 hours a day for 30 days. If you add that up, that's 14.4 kilowatt hours. And in Osaka, each kilowatt hour costs 25 yen. So the running cost for 1 month is 360 yen, and for 1 year, over 4,000 yen for this one bulb. For the LED bulb, it uses only 7 watts. For the same time, 8 hours for 30 days, it uses 1.68 kilowatt hours. So the running cost for 1 month is only 42 yen. And for 1 year, it's about 500 yen. So you can see there is a big savings. But when we invest or buy high efficiency equipment, we must consider the initial cost and the running cost. So the price for one old style light bulb, even now in a 100 yen shop, you can maybe buy 2 old style light bulbs for 100 yen. So a cheap cost is maybe 50 yen for one bulb. LED light bulbs used to be pretty expensive, but recently they've been getting a lot cheaper. I've seen this type of bulb for 800 yen, or even on sale, maybe 500 yen. But let's say 800. So that's the initial cost to start. And we just talked about the running costs. So if we add it all up, well, how do we add it all up? How do we consider both initial and running costs? And that's when we talk about payback period. The payback period is how long it takes for the running cost savings to equal the initial cost. So let's look at this. The light bulb costs 50 yen, or the LED bulb costs 800 yen. But we know the running cost becomes much cheaper. So comparing the running cost per month, the savings from 360 yen to 42 yen is over 300 yen per month is saved. So if you think about it, and then per year, it's almost 4,000 yen saved in 1 year. So this light bulb is more expensive. It's 800 yen, but compared to the savings, it's pretty small. The payback period here is about 3 months. After you save for 3 months, that's over 900 yen. That's more than 800 yen. So you win. It's a profit. So the payback period for this case is about 3 months. So in effect, you could say an LED light bulb, buying an LED light bulb is free eventually after 3 months. But further problem, when we calculate the payback period, we can't just compare a one-to-one bulb because of the lifespan. An old style bulb lifespan is pretty short, about 750 to 2,000 hours, depending on the use and the type. But an LED light bulb lifespan is much longer, 40,000 or maybe 50,000 hours. So let's be fair and let's use the best case. Let's say the best case for a old style bulb is 2,000 hours lifespan, and we'll use the shortest case, 40,000 hours lifespan for the LED. So that's 20 times the lifespan of an old bulb. So if we use the LED for its full lifespan, for the same amount of light, we need to buy 20 old bulbs. So again, this is a win. One bulb costs 50 yen. For the same lifespan as a 800 yen LED bulb, we need 20 old bulbs costing 1,000 yen. And that's not considering inflation. 10 years from now, maybe they're more expensive. So again, this is a win. Changing from an old bulb to a LED bulb saves money because of the lifespan and because of the energy savings. And if we do the math, going to the full lifespan of the 40,000 hours of use, that's if you're using 8 hours per day, that's over 13 years. And if we do the initial cost with one bulb versus 20 bulbs, then the running cost savings, a running cost total per year, and then running cost over the 13.7 years. To get the same light for 13.7 years, old style bulbs need almost 60,000 yen, and the LED about 7,000 yen. So total savings just to change from this bulb to this bulb is over 50,000 yen over the time of the lifespan of the LED bulb. So this seems very easy choice. Why would anyone use an old incandescent light bulb if there's so much savings? So let's talk about this. So let's think, why would anyone use an old incandescent light bulb? Then which would you choose and why? I think we already answered that, but there are some special cases maybe. And then should the government make a policy about light bulbs? So in class, this would be a discussion question, or perhaps we will write a report on these ideas. So personally, me, of course, I would usually choose LED, but not always. All of these calculations we did, all the math said we were using the bulb 8 hours a day, every day for years. But in some cases, for me, I don't use a bulb every day or not 8 hours a day, not even 1 hour a day. For example, in a closet. If I have a light in a closet, maybe I use it 5 minutes in a month. So to buy an expensive LED light bulb for a closet and almost never use it, maybe that's not a good case. So let's think of some other ideas. Why would anyone use an old incandescent light bulb? One possibility is just people with low income. For some people, having 50 yen or 800 yen for a light bulb is not a worrying problem. But for example, if you're on a pension or limited income or unemployed, or many are students, maybe you don't have that extra money to buy this LED bulb. Then even if you do have the money, maybe there's a low motivation to invest on the initial cost. For example, if you're students, maybe you go to an internship somewhere, a long-term internship for 3 months, and you get an apartment. You're not going to buy the LED bulb for the apartment if you're going to leave 3 months later. You'll think the cheap 50 yen bulb is good enough, maybe. I just explained the low usage case, the low total running cost. So light bulb in a closet, I don't use it much. So a cheap one saves money. And a much more bigger issue we'll talk about maybe in future lessons is the landlord and building managers versus the tenants. So who owns the building, who pays for the light bulb, and who pays for the electricity. So in many cases, and this is not just light bulbs, but landlords and building managers will probably initially, if they are initially giving you light bulbs, they will likely initially give you the cheapest light bulb. And then you can replace it later with a more expensive light bulb, because the building manager and that landlord does not pay the electric bill. You pay the electric bill. So they have no motivation really to get the best, most efficient light bulb for you. Unless they're using that as a sales point to sell a house or rent out a property by saying it's very energy efficient. But probably they will make it a higher price for rent or to buy. So please think about this. There are a few other reasons I can think of, but I don't want to tell you everything. So please think about what is your choice? What is your situation? Would you always use a LED bulb, or are there cases where you might use the cheap incandescent bulb? Okay. A part of that idea is that there are other costs than money. But we'll talk about that in the future. As for government policy, there are many, but this is a map of which governments have banned the manufacture of old incandescent light bulbs. So a lot of Europe, South America, North America, Australia, you cannot make incandescent light bulbs anymore. You can have them, you can buy them, you can use them, but you cannot make them. Interesting is Japan, it's still okay to make them, and we can still buy them easily at the 100 yen shop even. Some countries did a partial ban. The orange colors, maybe you notice a common point. The orange color says exchange program. And many of these are in Africa, developing nations, etc. So the exchange program usually is because the LEDs are pretty expensive, especially in a developing country, but maybe the government wants to save energy, maybe so they don't have to generate as much energy or save waste. Then you can bring an old light bulb, and then the government will give you an LED light bulb in exchange, and then you can use that LED light bulb. So that's one idea. And this was probably very common now because the math is so good. It's very easy to understand that LED light bulbs save money on every point. The lifespan is longer. They use electricity. The only maybe one of them minor minus points is maybe LEDs are more difficult to make and use materials and how to dispose of them afterwards compared to the old style light bulbs. Okay. Next time we'll start talking about energy saving policies because we must consider many aspects. Now, we were just talking today about reducing energy use and then reducing costs. Oh, it's the easiest one. And in the case of LED light bulbs, this was a simple formula. You save energy, you save money by using LED light bulbs. So many countries have now banned the manufacture. But as you know, it's not just money. We are also worried about reducing CO2 and pollution emissions, so for the environment. And then a little more difficult topic is controlling the peak power consumption. Sometimes, some places, there's not enough electricity during a busy time of day, especially in summer. On a hot day, many people use air conditioning, and there's a chance that there's not enough electricity for everybody, and then it can be a blackout or a brownout. Okay, so we'll talk more about these in the next lesson, but for now, that's all. I guess this is a good time where we would have a discussion or make a report assignment. So please check your class materials. Thanks for listening. See you next time.